Welcome to this video on the unit summary of Changing Climate for OCR B Geography for Inquiring Minds with me, Mrs. Shuttleworth. So the specification looks very much at the evidence there is to suggest that climate change is a natural process. So obviously looking at the evidence for climate change, if it's a natural process, and why climate change is such a global issue. So we know that the global climate has been changing since time began and will continue to do so into the future. The Earth's temperature has fluctuated in the last few hundred years. However, since around 1950, there's been a dramatic increase in global temperatures, and this increase is what's known as global warming. So the Earth's average temperature has changed over the last 500,000 years. There are times when the global climate is warmer, when you get these interglacial phases, and times when it has been cooler, these glacial phases, when there has been an ice age. So the last major cold period was known as the Pleistocene. It started 2.6 million years ago and ended just 10,000 years ago. Since then, conditions have been warmer. This current warm phase is known as the Holocene. Now, the Holocene and the Pleistocene are part of the Quaternary period of Earth's history. Now, if we look at this graph, we can see there are very clear times when the temperatures came above today's global average. You can actually see that there are 5 interglacials here and 4 glacial periods. And that what's really clear on the graph is that those glacial periods are much longer than the interglacials. So what evidence is there of climate change? Obviously, we have thermometer readings. So ongoing temperature recordings using thermometers have shown a clear warming of the Earth's temperature over the past few decades. Scientists found that the Earth's average surface air temperature has increased by about 1 degree since 1900. Be aware that although that doesn't sound very much, it is a lot, and we'll have a look at those impacts. The period between 2010 and 2020 was the warmest decade on record, with 2016 and 2020 being the warmest years since records began. The degree to which the climate warms in the future will depend on natural climate variability and the level of greenhouse gas emissions. So if greenhouse gas emissions continue, then average global temperatures will rise. However, some regions like the Arctic will warm faster than others. So this is a graph of our global average temperatures and how they've risen since 1860, when our records began. And you can see the graph goes from 13.5 degrees all the way up to 14.4. And it is a positive correlation with time. Have a look at this evidence. So you can see in this glacial retreat at the Muir Glacier in Alaska in 1941 to 2004. So photographic evidence over the past 100 years has shown that the world's glaciers have been melting, which has caused them to retreat. The increase in global temperatures is causing glaciers to disappear and is increasing the melting of sea ice in the Arctic. Now, our evidence, a lot of it comes from ice cores, which are used to detect changes in temperatures, because we know that when snow falls, it traps air into the ice. And when scientists take a core of that ice, it reveals the atmospheric gas concentration at the time that the snow fell. And that's used to calculate temperature at that time. So the ice can reveal the temperature of each year for the past 400,000 years. Now, scientists that study the ice cores say there's clear evidence that there's been a rapid increase in temperature in the past decades. But we've also had rising sea levels. So between 1900 and 2019, average sea level rose by 0.21 meters. Now, the causes of this are obviously natural and human. So a natural function of the Earth's atmosphere is to keep in some of the heat that's lost from the Earth. And we know that this is called the greenhouse effect. So the atmosphere allows the heat from the sun, that shortwave radiation, to pass through to heat the Earth's surface. The Earth's surface then gives off heat, long-wave radiation, and this heat is trapped by greenhouse gases like methane, carbon dioxide, nitrous oxide, which radiate the heat back towards the Earth, which is what heats up the Earth. Here it is in a nice diagram, one that you could perhaps pause the video and pop on your mind map sheet. You can see the solar radiation coming in, being absorbed and reflected. greenhouse gases obviously trapping that heat. Some of it can escape, but obviously the pollution is adding to that heat. There are natural factors which contribute to increased global warming. You've got those orbital changes, the Milankovitch cycles, those natural warming and cooling periods that are caused from these, the variations in the tilt, the orbit of the Earth, and the elliptical to circular orbit. Volcanic activity is also causes a natural increase in temperature or decrease in this respect. During a volcanic eruption, carbon dioxide was released into the atmosphere. Sulfur dioxide converts into sulfuric acid, and these aerosols act like little tiny mirrors that reflect back towards space. And then solar output, there can be fluctuations in the amount of radiation from the sun. If there is high amount emitted, there'll be an increase in Earth's temperatures. So here are the Milankovitch cycles in a diagrammatic form. Your eccentricity, 100,000 years to go circular to elliptical and back to circular. 26,000 for one wobble, so that's the precession, and the axial tilt from 21.5 to 24.5 takes 41,000 years. Now, this is where humans come in. So you have the natural greenhouse effect, and then you have the human-enhanced greenhouse effect, where you have more greenhouse gas. So obviously less heat escapes into space, and you have this more re-emitted heat. So it's a bit like putting a huge duvet on in summer, not the best idea. So some human activities are increasing this amount of greenhouse gas in the atmosphere. Obviously, we know burning fossil fuels like coal, gas and oil, these release carbon dioxide into the atmosphere. Obviously, they have sequestrated the carbon from the atmosphere or stored it as the remains of dead plants and animals for 200 million years. And now they're being released through the burning of them. Deforestation, obviously trees absorb carbon dioxide during photosynthesis. So if they're cut down, there'll be higher amounts of carbon dioxide in the atmosphere. I'm sure people, that makes sense. Dumping waste in landfill, when the waste decomposes, it produces methane. And obviously agriculture. Agricultural practices lead to the release of nitrogen oxides in the atmosphere and also methane through animals. Now, there are a number of greenhouse gases. We know that carbon dioxide is the one that we talk about the most. It's the most significant. It counts for 60% of this enhanced greenhouse effect. We burn fossil fuels. We use our cars, industry puts carbon dioxide into the atmosphere, and obviously deforestation. There's also methane. Now, this accounts for 15% of the enhanced greenhouse effect, but the actual amount of methane is quite small, but it's 25 times more efficient than CO2 at trapping that radiation. And this comes from landfill, rice production, and farm animals. Then you've got halocarbons, which we invented, mainly CFCs. They're human-made. They're a tiny proportion, but they're 15,000 times more efficient. So they account for 15%. They come from air conditioning units, refrigerators, aerosols, foam packaging. And then you've got nitrous oxide, 250 times more efficient than CO2, counts for 6%. Main sources, agricultural fertilizers and car exhausts. Now, this is your summary to know the key core content on your knowledge organizer. Have a look at that. It's very informative. And you know that you also have resources in the Essential Guide to Success, your overview, your specification checklist of changing climate. You've got your key vocabulary and obviously subscribing to our YouTube channel. Thank you so much for listening and best of luck with your revision.